Hello guys, we're very happy to see you again. I'm your friend InsideXO. Right, today our topic is learn how to use Keras to do multiple inputs and multiple outputs prediction. I'm not kidding guys, it's very important to learn this kind of technology because by using this kind of technology you can input multiple types of data. For example, you can input number and character and image data together to feed into the model and let the model predict things for you. By using this kind of technology, you can have a literally more accurate model than you do single type prediction before. When I get started to search this kind of technology, I mean multiple inputs, the top research result is an article of PY Image Research. From this article, I have learned if you want to create a multiple input model, first you have to learn how to use functional Keras architecture. To be clear, is to learn the Keras functional API in TensorFlow. I'm going to guide you down to this article. Let's get started. First, you have to import the TensorFlow STF. We all know the use of Keras sequential for creating models. The functional API is a way to create models that is more flexible than sequential. It can handle models with nonlinear topology, models with shared layers, and models with multiple inputs or outputs. It's based on the idea that a deep learning model is usually a directed acyclic growth of layers. The functional API is a set of tools for building graphs of layers. Considering the following model, you got an input layer, you got a three dense layer, and you got the output layer. It's a simple graph of three layers. To build this model with the functional API, you would start by creating an input node. By this, from TensorFlow import Keras. Imports equal to Keras that input, and you gonna give it a shape parameter. For this line of code, it defines an input layer with the shape of one-dimensional 784 elements inside that one-dimensional array or vector. Here we just specify the shape of our data, 784 dimensional vectors. Note that the batch size is always matted. We only specify the shape of each sample. For an input means for images of shape 22, 22, and 3, we would have used image inputs equal to Keras that input with the shape of 32 times 32 times 3. The 3 here stands for the RGB channels within an image. Here we can see a simple example here. First, we define an input layer with Keras that input by giving it a shape. Then, we create a dense layer. By using layers that dense give it the load number 64 with an activation function as a parameter. Then we give that input layer to the dense layer. Then we create another dense layer to receive the outputs from the last layer. Here is the X. Finally, we create the output layer by using layers that dense, and we give that middle layer X. Finally, if everything just goes fine, we can use Keras.model. Inputs equal to the input layer you just defined before, and the output layer you just defined in here, and give it a len. Is that simple, right? I'm pretty sure that I don't have that kind of knowledge to explain everything for you guys. What I could do is read the article sentence one by one and to do my best to collect each of them as reasonable as possible. Here, just imagine we're gonna do more complex model building. Let's say we are building a system for ranking customer actual tickets by priority and routing them to the right department. Our model will have three inputs. Title of the ticket is a text input. Text body of the target is also a text input. Any text added by the user is a categorical input. It will have two outputs. The priority score between 0 and 1. It's a scanner signaled output. The department that should handle the ticket is a softmax output over the set of departments. Let's build this model in a few lines with a functional API. The number tags equal to 12. The number of unique actual tags. The number words 10,000. The size of vocabulary obtained when pre-processing text data. It also means how many unique words we have in the text data. Number of departments equal to 4. The number of departments for predictions. The title input equal to Keras that input shape with none. Then equal to title. The body input equal to Keras that input shape none. Then equal to body. The text input equal to Keras that input shape with the number of tags. Then text embedded each word in the title into a 64-dimensional vector. The title features equal to layers that embedding number of words to 64-dimensional vector, and we gave it the input layer as a parameter. Then we embed the body that underlying features equal to layers that embedding number of words to 64-dimensional vectors, and we gave that embedding layers a body input as an parameter. Then we reduce the sequence of embedded words in the title into a single 128-dimensional vector by using layers that LSTM 128, and we gave that middle layer title features to the LSTM layer. And also, we reduce the sequence of embedded word in the body into a single 32-dimensional vector by doing this. In the end, the most important part about the whole idea is to merge all different layers variable into a single large vector by concatenation. You can do this with layers that concatenate, and you give it all the inputs all the outputs, whatever, all the layers that you want to merge together. You just type it down here. You can see the title features and the body features and the text input. They just add it together. Then we define two different outputs. The priority prediction equal to layers that dense one node because it's just a number. The activation equal to sig mode. The lamp equal to priority. And we give this dense layer a parameter x. This is the x layer. It's the biggest layer we had in this model. Department prediction equal to layers that dense the number of departments. Activation function equal to softmax. The lamp equal to departments. And we also have to give this layer a x as a parameter. Finally, we have to add all layers together. To construct a model, we have to define the inputs and outputs. Here, the inputs equal to the title input here, and the body input and the text input. The output equal to two layers. One is the priority prediction. Another is the department prediction. If you are curious about the structure of your model, you can print it out by using utilities plot model, and you give it that model, and you can define the path for the output image. And finally, you will get an image like this. It shows the inner instruction about your model. And then we could compile that model. After the compiling of your model, you can feed your data into it. At this time, the lamb here and here and here becomes very important title body text, because when you feed data into it, you have to give it a dictionary, and each item name is defined when you build in that model. Here is the title, body, and text. The whole dictionary is the inputs and also the outputs. You have already lammed the two layer with different lam. The first output layer lam is priority. The second output layer lam is departments. So here, when you feed data into it, the output data is fed through a dictionary with the lam that you defined before. Okay, that's the basic idea of how functional API works in Keras. If you have any question, feel free to go to the TensorFlow official website to learn more. I'm pretty sure that they have a community that's quite open for you guys. Okay, that's it. I will see you in the next video.